So I put a barcode, or rather QR code, to download the slides if you'd like to follow along. And I'll also put it up at the end of the talk as well. Thank you for being here. My name is Sergey Kirshner. I'm a co-founder and CTO of Fantastic Voyage Labs. We're a young startup building an adaptive learning platform to help people acquire hands-on skills. So we're starting out with building a series of VR simulations to teach people how to work in biosciences labs. What I'm going to do today is to give you kind of like a crash course on what does it take to build an animated instructor for a VR learning application. So without further ado, I'll let the instructor introduce herself.
Hi, I'm Celly from Fantastic Voyage Labs. We transform learning hands-on lab skills into a VR adventure. Nice to meet you.
All right. So this is Celly. She's our animated pedagogical agent. I think this is the formal name for an avatar like this. And we had to come up with the concept and develop her very early on in our adventure because we realized that in order for a learner to acquire skill, first of all, they need to be focused. And we need to provide them with something to focus on. So an avatar like this is absolutely essential to grab the attention of the learner. And this attention will increase interaction and will help the learner to build an emotional connection with the instructor. The avatar itself also provides a social presence. There is kind of this concept of persona effect that if you have somebody who looks like a human, behaves like a human, another human would be able to connect to them. And that would reduce the anxiety because there is another human with you there helping you learn. And then such an instructor would provide a perfect nexus to provide adaptive instruction to the learner and improve outcome as a result. So I guess one of the questions is, why did we decide to do it ourselves? Why did we, for example, look for a third-party solution for something like this? So one reason is that we did not want to have a human instructor. We wanted to have an instructor who has some human properties. And we felt that a cell would be a perfect guide for somebody who wants to learn to work in a lab. We also felt that would be a very important component for us because this would be, again, our nexus to the learner. And we did not want to give up control in building this component. And we wanted to be able to add personal touch. And to be honest, something not on the slides, it was fun to build. So the scope of the talk is what goes into building an instructor like this. So I will primarily focus on the visual aspects and then aspects which are related to the communication of the instructor with the learner. I will cover the creative process of creating the form and shape of this avatar. How do we actually make it work in VR? How do we make it talk? How do we make it listen and understand? What kind of additional touches we might want to add in order to make it more realistic? And I won't have time to talk about motion, unfortunately. And what kind of interaction we wanted to include to begin with so that, in the very least, we can build on later on and something that would be functional almost off the start. Okay. So before I move on, I want to acknowledge the people who actually did the work. So I'm here to present it. We have a fantastic 3D props and environment artist, Taras Vozny, who created Celly. He built the form and shape for it. He made it appear what she is. And then Pavel Kucherina, who actually made Celly communicate with the learner. And the rest of our engineers, Daniel Yu, Connor Gorodny, and Sergey Putyak, who helped refine Celly's behavior and Celly's capabilities. So let's start with creating the shape of the avatar. How do we do this? And it's a creative process, and it's an iterative process in nature. So we start out with a goal. We want this avatar to enhance the engagement of the learner and make it more interesting for the learner to perform the simulation. And we want the learner to be comfortable so that when they're comfortable, they're more likely to absorb the knowledge. But we do have some requirements. So as I mentioned, one of the core requirements, we wanted our avatar to look like a cell. We wanted the appearance to be friendly and non-threatening and non-distracting. We wanted the avatar to be able to move and to talk to the learner. And again, we wanted the instructor to help the student make mistakes, learn from these mistakes, listen to what needs to be fixed, and continue learning in that way. So how did we do it? So we needed some inspiration. So we went to the web and started looking, well, what kind of cells are out there? What looks like what we want? And what can we start with as a concept and try to build on? So we looked for animated cells. We looked for something which looked more scientific. We looked for something which was more stylistic. None of it, of course, we did not want to borrow somebody else's work. We wanted this as a starting point, but this kind of gave us a couple of ideas. And the next step in all of this, and it's kind of very difficult for me, I'm trying to capture the artistic process, something which requires a lot of inspiration and imagination. So we needed some help, so we created a mood board, which tried to capture properties that we wanted to have in our instructor. We wanted friendly face. We wanted a face that could talk. We wanted to figure out what is the right color palette to use, how to set up the environment, and actually how to place the instructor in a setting where they would be interacting with the learner and maybe providing them some instructions. And then the rest of the process is almost like magic, except that we tried also to use generative AI. And unfortunately, it did not quite come out as we expected. Either it looked too alien, or too cartoonish, or too busy, but it didn't quite capture what we wanted. Maybe we weren't particularly good with prompt engineering. Maybe the technology has improved, and now it can produce something more imaginative. It didn't quite work for us at the time. But still, even after that, even having human artists who tried to figure out, capture the requirements, and use his imagination to come up with different candidates, it took us a number of iterations to get where we wanted. So the first iteration at the bottom, I guess right, was too cartoonish and maybe too distant for us, not really a representation that we wanted. A couple of iterations later, we created something which was more reasonable, but perhaps was still too busy. And after a couple of iterations, I think it took us several weeks to come up with something that looked just right. And if you've seen Celly in the beginning, that's what Celly looks now. So once we have an image, now we need to actually create a 3D model to use it in VR. And there is a fairly standard process for doing this, but I think it's still worth going over. So the first step is sculpting. You literally take something which looks like a virtual clay, and you try to mold it into the shape that you want for this. And once you've done this, you end up with something which looks very busy. I think it's the image on your right. It's a high polygon count model, something which captures a lot of the shape that you want to have in the avatar, but perhaps too complex to run in VR. So what we're trying, in essence, to do, we're trying to simplify it as much as possible while preserving the characteristics of this original 3D model. So we want to go from high poly model to low poly model. So the first step, I think it's called retopology. We create a new model, but we try to preserve a lot of information about the old model. So the idea is that we want to keep the basic shape, but we want to put more information into the areas which would need to move quite a bit. So for example, the avatar would be talking, so we want to make sure, say, that the corner of the mouth have a lot of information preserved so that we have better ability to manipulate, and same thing for the eyes. Once this is done, there is the process of UV unwrapping. It's a fancy term of taking something which is 3D and in essence carving it up into 2D, not really shape, but strips. So what we would be doing, we would be now overlaying more rich information over these 2D shapes rather than over 3D shape. So one good analogy is, imagine that you have a cylinder that you want to unwrap. That's what UV unwrapping would do. It would take the surfaces and kind of separate them from the 3D shape. The next step is so-called baking. The idea here is that we want to transfer some information from the high polygon count 3D object to the low polygon count 3D object. So we're trying to preserve, for example, some reflectivity of the object, so that and some of the details like scratchiness or kind of some micro shape information, so that the new object looks like the new object, while more efficient, has the properties of a more detailed object. And the final part is to add additional texturing. So we use the standard physics-based rendering workflow for this, trying to transfer, trying to set up the colors, set up whether the object is metal or not, this type of reflectivity, and also setting up additional information about the texture, like little bumps around that you can see on the Celly on the left. Okay, so now we have a 3D model which we can run in VR. Now we actually need to make it communicate. So what do we do here? So the first thing, we wanted to give Celly voice. Well, how can we give an avatar voice? There are quite a few different packages which we can use for speech synthesis. So I'm not specifically advocating for this one, but again, we're a small, scrappy startup. The first thing that we do, we use Meta SDK, and we say, okay, well, why don't we try to use Meta's package for voicing? So we decided to use with AI. It's something free to use. For small projects, I guess it's okay. And what's nice is it has really easy integration with Unity. So we did this. It provides a number of different voices in the library. We experimented a little bit with this and found a nice female voice that worked for our application. And then we realized, okay, so WIT usually runs on the cloud. Do we really want, every time we want Celly to utter something, do we really want to send a request and wait for it to come back? Internet sometimes doesn't work. So we decided to move it locally. Since we started out with static narrations, all we needed to do is to build a pipeline to take the text narrations that we wanted Celly to utter, and in essence pre-bake it, convert it into WAV files so that we can just play them when Celly is supposed to communicate information to the learner. So this requires building a pipelines which first convert text to speech, and then part of this pipeline would also maintain what happens, for example, if some narrations get changed. But this only works with static text. So what we can potentially do, and something that we will do down the road, we'll simply implement, or we'll find a package to use locally for text-to-speech. The problem there is that it does take processor cycles. So we need to be mindful of this. But at this point, we were OK with static narration. Now, the next piece.
Fantastic Voyage Labs.
One of the Cellys talks like a ventriloquist. So her lips don't move. The other Celly actually moves her lips in sync with the voice. Since we're not...
Fantastic Voyage Labs.
Oh, there we go.
Fantastic Voyage Labs.
Since the learner does not expect a ventriloquist...
Fantastic Voyage Labs.
All right. Since the learner doesn't expect a ventriloquist instructor, we need to figure out how we can make Celly really talk, really speak, rather than just have the sound come out. So there is, again, a standard process for this. English language has 44 phonemes. These are the basic components of speech. And every time we utter a phrase, this phrase can be broken down into these phonemes. And turns out when we talk, our face also has these basic shapes. They're called visemes. So these phonemes, they map to visemes. So all we need to do, we need to encode these visual shapes, in VR they're called blend shapes, to match different phonemes that the avatar would need to utter. So we used an open source framework, ulipsync, to map the two, but we still needed to create the blend shapes. And I have an example here on the right of how some of the human vizims correspond to Celly's vizims. And by the way, vizims, something which can be also used to capture emotion. That's not somewhere where we're not there yet, but it's something we can do in the future. For different languages, for example, we need to come up with different vizims, because again, people would pronounce things differently, the mouth would move differently. On the right, you see what happens when we transition from one vizim to another. There are only 15 vizims in the English language, and one of them is actually a neutral phase silent vizim. So that's what we needed to implement. And that actually made Celly talk with proper lip sync. Next, Celly needs to be able to listen. So for listening, again, we wanted to use some kind of off-the-shelf speech recognition module. So the best we found was it's a paid asset at the Unity store called Recognissima, which under the hood uses an open source VOSC model, which covers a number of languages. I think there are 8 languages in there. English is covered as well. So the key here is that we did not want to rely on internet connection because, frankly, we did not want to send utterances to a third party. We wanted to be processed on a device, no lag. So that's something which was really appealing to us. Now, Celly does not know a priori when you're talking to her, so we need to somehow indicate, we needed to have some kind of wake word, a wake phrase. So we chose, hey, Celly, like, what would you expect? And what do you think is going to happen next when we do this? All of the stray Apple devices start responding to us. But it's appropriate here. We might change it down the road, but it worked out fairly well. So once Celly has the attention of the learner, there is now a 10-second playback buffer, or rather 10-second buffer to listen for the command from the learner. And once that buffer is done, then the learner needs to issue another wake command. So, okay, now Celly can both talk and listen. And is it enough? So Celly on the right looks like it wants to hypnotize you. It stares at you, you stare into her eyes, and everything goes blank. Celly in the middle is actually behaving like a human. The pupils twitch a little bit, the eyes blink. She actually tries to center the gaze on the learner. If you come too close to her, she would lower her gaze. There is an absolutely fantastic plugin. Again, it's an asset on the store called Realistic Eye Movement, which allows you to implement all that. So we felt it was important to have a more realistic behavior from the avatar. We also added a little bit of idle gyrations of the outer membrane and a slight figure 8 pattern and kind of subtle canal movements to give Celly more floating appearance, which also makes it more natural. Okay, so what do we want Celly to do at this point? We want her to be a basic conduit for the learner. So we want learner to be able to talk to Celly, even to navigate around the lab. For example, teleport, or maybe turn, open menus. And then we want Celly to narrate the instructions. Tell the learner what they need to do. Tell them, maybe give them some hints. Tell them of the errors that they're making. And what I described to you accomplishes this purpose perfectly.
Put on the lab coat by taking it off the hanger to your left. Put on the safety glasses. They're on the table in front of you. Now, let's go to the BSC.
Hey, Celly. Take me to the biosafety cabinet.
Put the gloves on by touching the glove box with each. You forgot to put on glove. Put the gloves on by touching the glove box. To remove potential contaminants, spray all BSC surfaces with 70% ethanol.
Hey, Celly. Repeat.
To remove potential contaminants, spray all BSC surfaces with 70% ethanol.
Hey, Celly. Open menu.
All right. So it gives you an idea what basic implementation provides to you. It's actually fairly easy to put together. So where do we want to go next? We actually want to make Celly teach the learner, not just interact with the learner. And doing this requires adding a bit more functionality, something that we're working on. We want the help and the feedback that Celly provides to the learner to be more contextual. So for example, a learner might get stuck, and based, for example, on what they're trying to do, what they're looking at, what they're touching, what they're not doing. We want to tell them or give them gentle nudge what to do next. We want to be able to encourage them. We want to be able to provide general feedback, like slow down if they're trying to do something and maybe they're doing it wrong. We do want to hook up a conversational agent to this, although we're probably going to be very conservative about this. That requires hooking up some kind of large language model. We are, or rather we will implement at some point support for other languages. And the framework that I described to you, even though I described how to do it in English, the very small tweaks need to be done in order to support other languages as well. And then I think the key part to it is that we can add a lot of fun to learning. We can add more emotion. We can add funny movements. I keep thinking of Mike Wazowski from Monsters, Inc. in terms of what kind of things we can do. We can add funny phrases, something that will make the learner want to come back. All right, so what did we learn in all of this? So very early on, we realized we need some kind of focus of attention for the learner. And that's where Avatar came to be. We also learned that it's fairly straightforward to do it ourselves. So it took us in the order of 2 months to put together, I think about a month of work from the artist and about a month of work of the developer to put this in. Obviously, something that we need to keep iterating on, but even the process of putting this together was highly iterative. I think that was the main takeaway. You can come up with a concept, but it will take quite a bit of time to iterate to get it, I wouldn't even call it right, get it better. And then small touches do matter. The little twitches in the pupil, getting the gaze right, getting lip sync right. These are the touches which make the instructor look more like a person rather than like a zombie. So I think it's important to put some effort into that. So if you haven't stopped by yet by our table, please do so. You can meet Celly, and you can try to learn how to pipette. Well, thank you very much.
First of all, great presentation. Thank you for that. And I'm sorry, I might have misunderstanding this, but I'm curious about the texturing you talked about. What thought process went into the colors you chose for your AI agent? So that's probably a better question for the 3D props artist. Okay. If you want, I can connect with you afterwards and try to answer your question. I might need a little bit of feedback. Cool. I can stop by at the table. Okay, that sounds good. Thank you. Thank you.
This is our last
question. There's a question up front. Yeah. Okay.
I noticed Celly had a lot of these kind of voice commands that you would be able to use to ask them to do different things, like teleporting, a couple of things. How do you onboard the user into knowing what kind of things they can say? How do you first tell them they can say, "Hey, Celly"? What does that actually look like for a user who's new to the application? How do they know what they can say?
Great question. So we actually have a tutorial module that has user try this command. So Celly tells them, "Hey, try teleporting here." So say, "Hey, Celly, take me to the biosciences cabinet," for example. And Celly would do this. And they, in essence, have to follow a scenario where they have to issue these commands to see what happens to them. Yeah, we ran into exactly this issue at first. We implemented all of this, who knows how to do this. And we have a help screen, but even if you're there, it's like trying to learn how to sing from a book. Probably not going to work, so let them try it out. All right. I think I'm at time. Thank you very much.